So convolutional neural network, how does it work? Suppose we want to detect X in this image. What we really want is detect this diagonal feature. And for the same symbol X, it have some rotated or deformed version. So one filter may not be enough. The convolutional operation is the element-wise operation, and the place where it perfectly matched the filter is will give us the highest response. So this filter what we want to detect is this diagonal feature. And then so in the grid line, in the green box, it gives us the 9, which is the highest score. And so different filters can give us different features. The only difference is the 9 elements in this square. And so the whole process, suppose we have a grayscale image and we want to use a filter to get its feature maps. So we slide through this whole image from the top left to the bottom right. And we can, and also we not only want one features, we want multiple features, so we use multiple filters. And then after that we the max pooling. Max pooling is the 2 by, so the size in this case is 2 by 2, and we want to get the maximum result. It reduces the computation and also doesn't lose much information. So the whole process is given an image, we can repeat the convolution 2D and max pooling many times. And also after that we flatten it and connect to a fully connected neural network. So in our case, the input image is the RGB. It's not just grayscale. So instead of using 3 by 3 filter, we use 3 by 3 by 3, which is a cubic. It's also an element-wise operation. The only difference is in this part, and the rest computation is exactly the same. And so why do we need multiple Com2D and max pooling? The reason uh, is is here. So suppose in the initial part we have the initial information, and each grade has this is just the number, like the number of features. And after a 2 by 2 filters, we combine this 4 information into one grade. So this one contains more information. And we apply a 2 by 2 filter again, and this combine this 4 which give us 16 features. And then this at the end, this is just like the input features of the fully connected neural network, and we flatten it. And also because we shrink the size, it doesn't lose much information. So the low level features maybe in the first convolutional layer, maybe some lines, edges, and the middle level features maybe the eyes, ears, nose, and the deeper the layer it is, it see the more information, see the global information. And our implementation is as follows. So we tried 2 different depths. And turns out this achieve higher accuracy. Uh, and so this is the input channel, which is RGB, and we want 100 feature maps and apply a 5 by 5 filter. So how do we get the 16 times 5 times 5? So the number of output features is 60, and then the 5 is, so the image size is 32, and we apply a 5 by 5 filter. It's 32 minus 5 plus 1, which gives 28. 28 divided by 2 is give us 14 minus 5 plus 1 give us 10, and we do max pooling again, give us 5 by 5. I would say the reason is the depth soup works better is because this is more suitable for the entire data set. And also the result is we stop before validation loss start to increase. And some super classes, I would say this is pretty good. There's just some. So in this case, it doesn't classify very well because some superclasses have features that are really difficult to differentiate. For example, small mammals and insects. I would say this is even hard for our human to distinct. And we also, so the next thing is we use a slightly involved version of convolutional neural network, which is ResNet, and Bing Qi will introduce that.